Hey everybody, let's take a look today at equivalent expressions. This is from IXL Y.17, Identifying Equivalent Expressions Part 2. So what we're looking for is to see if any of these orange expressions are equivalent to the blue one here at the top. So if we think about our blue one, we have two x's here, plus there's that 1 hiding right there. So in all, we have 3 x's. Right? If we add these two together, we get 3 x's. And since we're adding, we don't have to do x squared or anything like that. So it looks like we have a 3x right there. Here we have a 3x plus 1 more x. So this is really 4x. So that one doesn't work. This would be a 1x plus another 1x. So that's really only equal to 2x. And this one says 2x. So that doesn't work in any of those cases. But this one is correct. Let's look at another one. Remember, we could have more than one answer. Now here together, we have 7 plus 6. That would be 13t. Well, let's see. I think we can roll this one out because t plus 13 doesn't work. This one's only 12t. Now this one looks like it might be right, but this is t to the 13th power, and we only have 13 times t, so we can rule that out. So it looks like we have t times 13. Remember, order doesn't matter here. We could switch these around and have them be on either side. So that one looks fine. And then we said 13t was our actual answer, so we have 2 answers that are correct this time. Let's take a look at this one. This is 2 times 8n. Well, let's see. Using the distributive property, this would be 2 times 8, and we would leave the n alone. So it looks like this 16n is probably pretty good. This one, 8n plus 2, doesn't seem to work. We already have the 8n, but we're multiplying by the 2, so that one we can rule out. N plus 10, well, we wouldn't add the 2 and the 8 on the initial problem. We'd multiply them, so we can rule that out. 2 plus 8n, well, that's just essentially the same thing, so we can rule that out. Now let's think about this one. This one has a 1 hiding right here, so if we combine the n's, we would get 1n plus 7 more n, which is essentially 2 times 8n. So this answer is correct along with the one at the bottom. So again, 2 right answers. Let's take a look at this one now. If we think about this, 9 plus 2, that would be 11 total m's, wouldn't it, if we add them together? Well, let's see if we have any 11 m's. Well, obviously we've got one right there. Let's see, together, this 2 plus this, 10, would equal 12m. So we can rule that problem out. 8m here plus 4m here, that would be equal also to 12m. We can rule that problem out. 7 plus 4, however, 7 plus 4, that is 11m. So it looks like we have 2 correct answers on this problem. Okay, let's look at this last one. We have 5f plus f. Well, keep in mind, with every variable, the coefficient 1 is hiding in front there. So in total, we have here 6f, right? Well, good thing. Here's 6f right there, so we know this one is obviously correct. Let's see if we have any others that would work. Here we have 1, 2, 3, 4, 5, 6 f's right there, and each one of those has a 1 in front of it. And so hiding there, if we add all of those together, we would get 6 f's in all. So this one works. Down here, we could add the 3 and the 3. That leaves us with a 6f right here. This problem's correct. This is a 1f right here with another 1 hiding in front of it. So we have 1f plus 4f plus 1 more f. That gives us 6f. This problem's correct. Now this one we don't want to get fooled. Yeah, there's a 1 hiding in front of each one of these also. But this is multiplication. So f times f times f, this would be f to the 6th power. That's a much different answer. Not what we're looking for on this problem. Okay, I hope that clarifies what we're looking at here using equivalent expressions. Be careful, there are some tricky ones, but pay close attention and you'll do just fine. Okay, look at Y.17 in IXL again and see if you can get your SMART score up to 80. Awesome.